Okay.
Okay, welcome to my electrical test presentation. 36 years ago, when I first opened Walridge Motors, I was getting a good deal on boiler kits and was selling one or two every day. Problem was, at least once a week I was getting one back as a warranty claim, and I'd be sending them back to boyers in England, and in almost every case they would come back with them saying there was nothing wrong with them. So I set about building this motorcycle electrical system in a box. The intention was to fit a rheostat rather than an on-off switch so I could vary the speed, but I never got to that yet anyway. What about finding a way of connecting mags and dynos on the other side, but that's another thing for maybe in the future. Anyway, this machine has everything on it that you would find on most mid-60s right through the 70s British coil ignition machines. Yeah, more electrical test questions than any others. And the first thing I always ask a customer is, do you know the difference between a volt, an amp and an ohm? If they say no, I tell them to find a friend who does, to talk to me, because otherwise we'll just be wasting each other's time. Something that needs to be understood is that almost every vehicle in the world has three parts to its electrical system. Something that makes the electricity, that is in this case an alternator, which feeds a rectifier to change AC to DC, and a Zener diode to regulate the current. There are also more modern power boxes, like that's a Padronix, which takes the place of a rectifier and a Zener diode. Over the years, we've seen Mighty Max, Timpanium, and Boyers also do a similar product. Anyway, so that makes the electricity. Then you've got to have something to store the electricity, usually a battery, but in some cases there's a capacitor, the blue thing on a spring, or just a capacitor on its own. Anyway, that's what stores the electricity. And then there's something that uses the electricity, which would be the ignition, the lights, the horn, etc. Those three things are largely unrelated, and each can be tested in isolation. Replacing the alternator stator will not cure a misfire on one of the plugs. Believe me, I get this kind of question every day. So let's have a look at this machine. It runs at a steady 1,750 revs per minute. Now, this is a regular RM21 type Lucas alternator, most commonly used on all these British bikes. If I put a new rotor in there, I will get RPM. If I look at this particular one, let's set the voltmeter to AC, and let's hook it up to the two wires coming off the alternator. Doesn't matter which way round, of course, although I do get asked that question quite often. And we run it there. We're reading 16.4 volts AC. That means that the rotor has lost maybe 25%, 20 to 25% of its magnetism. Okay, should be all right for general riding, but it's not as good as new. Sometimes we put them on here and they read 8 volts or something. Well, you're going to have to rev it pretty fast to keep your battery charged up. Some of the earlier stators had 3 wires. They are exactly the same as the 2-wire type. Originally, they had the 3 wires with 2 wires connected to the rectifier, and one wire connected to the lighting switch. That wire, what happened therefore was that the lighting switch would boost the full output of the alternator only when the lights were switched on. They found that Zener diodes were pretty reliable, and so they changed to the 2-wire type by connecting the wires inside. If you've got one of the early stators and it looks like it's all right, all you got to do is connect the black and green wire to the black and yellow wire together and fasten that to one side of your rectifier, and connect the green and white wire to the other side of the rectifier, and it'll work exactly the same as this one. You would expect stators don't usually go wrong. They either work or they don't. So if you check the resistance, that means setting your meter to ohms. If you check the resistance on the 2 wires through the stator, you should get between about 0.6 and 0.9 ohms. This will take a second to settle down. There you go. That's good. You should also check each winding to ground to make sure you don't have an open circuit, which would indicate a short inside the stator. You won't get that, so open that way. If you got that one, open that way, so there's no problem there. If you had a resistance or a measurement there, you'd know that there was something wrong inside the stator. Anyway, our stator seems to work fine. Okay, so we've talked about the stator. There we go. I've got a solid state rectifier, a little silver thing like that. I used to buy them from Radio Shack. We carry them supplied by Boyer. I don't think I've ever heard of one going wrong. The only way you can hurt a rectifier, be it that or this one, the best way to hurt a rectifier is to hook the battery up backwards, even for 1 second. If you hook a battery up backwards for 1 second, your rectifier is toast. You might as well throw it away. Okay. Okay. If you want to know how to connect a rectifier, on the solid state ones, it's marked AC, 2 AC terminals, 1 positive, 1 negative. With the regular Lucas type 49072 rectifiers, they're called a bridge rectifier. The outer 2 terminals are AC and the middle terminal is DC. Some of them have a ground connection on them, some of them don't. If they're bolted well to ground, they don't really need that one. It's just somewhere to put an extra wire if you've got a ground. Okay, the alternator, we've talked about that, haven't we? Okay, now the output of it, because it's called a full wave rectifier, what the rectifier does is it takes one of the input pulses from the alternator and it turns it round to join with the other one, therefore creating DC. It's being a full wave rectifier, it should kick out approximately the same DC voltage as is going in AC. So if we hook this one up here, I'm basically connecting it to the alternator there, connecting the alternator to the rectifier through the wires here. We should have an output. I'm just going to disconnect the light for now. Where are we? There we go, got too much here. Okay, now I'm going to check the DC output on the So that came out about 17 volts, so that's good. Then when we connect it down here to the Zener diode, of course, without the Zener diode, 17 volts would not do your light bulbs a lot of good. So now we're going to test what the voltage out is when the Zener diode is hooked up. DC there. 12.6 volts. So the Zener diode is doing its job, and ooh, if I touch it, ooh, it's hot. Okay, so that dissipates it burns off the extra voltage of heat. We had a guy in BC at one time who returned a Boya kit because it had failed, and Boya very nicely replaced it under warranty. I sent him another one. 2 weeks later, he's telling me Boya's a crap, the next one's failed. I said, well, could you test your bike, and how's your Zener diode? He says, what's a Zener diode? So basically, every time he revved the bike up to 4,000 or 5,000 RPM, he was kicking 30 or 40 volts into the Boya, so they wouldn't do the warranty the second time. Okay, now where are we going next? Okay, so we've covered that. Yeah, when we were teenagers, we rode fast and kept the revs up high, so batteries rarely went flat. But if you're on a vintage club road ride, doing 40 miles an hour in top gear with the lights on, or riding in heavy traffic, you need a good capacity battery to cover the time until you can get riding faster. Most often, people with charging problems and wanting to change to a high output or three-phase alternator, 90% of the time just need a new rotor. Now we're going to switch the lights on and see the voltage drop. Okay, so we saw about 12.9, I think it was, wasn't it? Was our figure 12.9?
12.6.
12.6. Okay, so now we're going to hook the lights up, which I think we do like this. I don't know what that wire does. That fills you with confidence, doesn't it? Okay, we'll turn the lights on, and the lights don't work. Oh, bugger. Okay, now we're going to turn the lights on. See there that from over 12 volts down to 6 volts because of what the lights were taking out of it. Next, what I could do is hook up a Boya kit. So here's your Boya. So with the Boya, white wire is the power. That comes from your ignition switch, so I'll hook that on the end of the Zener diode there. Red wire goes to ground. Let's hope we've got a spare ground wire. Here we go. By the way, this is the frame of the motorbike. Okay. Then the black wire goes to the coils. Most people are familiar with that. The coils are connected to each other and then to ground. This is the positive ground way of doing it. And then we've got the pickup here for the Boya. And you've got that, it goes to the black and white. Don't reverse the colors when you do this. It does weird stuff to the timing. Okay, like that. And then even at 6 volts, we're still getting a spark on the plugs. This is because the Boya Mark IV will run at a lower voltage than the earlier ones, but it doesn't do to run them at a low voltage because they do have a tendency to kick back. Okay, now what I'm going to do is I'm going to hook up a battery and we'll see what kind of a difference that makes. Okay, now let me think this through. I should have rehearsed this. Okay, are we ready? Okay, so now we've fitted a 12 volt battery. I'll read the voltage on that. It should be fully charged. Oh, yeah, it should be right. 11.87. Okay, it's close. Okay, there's my battery fully charged. It's down a little bit, 11.9 volts. Okay, we've hooked the battery up. The positive side is to ground, and the negative side will be connected to the Zener diode and the rest of the ignition system, the rest of the electrical system. So now what I'm going to do is basically switch it on. Now with the lights on, the battery voltage falls to 6.49. Let's start it up. We start the bike. I'm switching it off now, is that the spark on the spark plugs was a lot brighter, but we were still low, well below 12 volts. So basically, if we rode this bike out for a day at 1750 RPM, which is pretty low, the alternator wouldn't be turning fast enough to match what was coming out of the battery, and we'd be calling the CAA after a while because the bike would stop. And just as an interesting side, I'm going to hook up an LED headlight bulb and see if that makes a difference. Okay, you can, the previous bulb, the bulb that's in here, is at 60 watt halogen type. Okay, if you want to stop. Got pretty hot, that did. Ooh. Awkward if you don't show it. Now we've put in an LED bulb, one of our nice daylighter ones. So we'll hook the lights up again, like that, and then we'll start the Okay, 9.75. Turn the lights off. Definitely with the LED bulb we've got a greater voltage, but we're still at 1750 RPM, not going fast enough to keep the battery charged up. Okay, right, I think that covers most of what I wanted to talk about. Yeah, okay, last thing I'm going to do is I'm just going to talk about boyers a bit because we get so many questions about them. Okay, last thing I'm going to talk about is boyers. I also cover this a bit in my blog, which you can get off our www.woolridge.com website. The same principles I'm going to talk about also apply to other electronic ignition kits. If you think there's a problem, first thing is hang the plugs on the side of the motor, tight to the motor, and see if they spark. If the spark is very weak, remember that a plug needs a lot more voltage to fire under compression than it does in the open air. Okay, don't leave one plug dangling on a lead. It must have somewhere to go. The coils don't like it if you do that. You should see a good bright spark. Remember, okay, these kits read the voltage created by the magnetic rotor inside the stator. I've never in 36 years seen a rotor go bad. The stators are quite easy to test, but they are a little alternator. The two coils don't each fire a cylinder like the thyristor type do in the old Japanese bikes. All this does is it creates AC voltage, and the speed of that voltage controls the advance and retard of the spark. The two tests: number one, disconnect up the two wires up near your black box, okay, and test the resistance on those two. So set that to ohms and we'll test the resistance. Hopefully we should see 135 ohms give or take 5%. What do you get there, Zulfikar? Oh, look at that. 131 ohms. Now, while you're doing that, have somebody else go down by the pickup and wiggle the wires around like that. That may seem a little strange, but quite frequently on commandos, you'll see the reading jump all over the place. And what happens, we don't know commandos vibrate, or you don't know they do, but they do. You just can't feel it. And they tend to break occasionally the wire out right inside the insulation close to the pickup plate. I've seen that happen quite a few times, okay, over the years. If you get a reading of 60 ohms by what I just did, you've got a 40-year-old Boyer kit, probably, because they were lower ohms back 40 years ago. And there are still of them still running. Okay. Now, next test with a Boyer. Take the wire that comes from the black box to the Boyer and goes to the first coil. Check the resistance between that coil, there we are, we're on ohms. Check the resistance between that point there, we're getting all knotted up here. All right, between that point and the negative terminal on the battery. You should see the positive terminal on the battery. God, how did I get this job? You should see about 4 ohms, anywhere between 3.5 and 4 ohms. Can you see that? Okay. Therefore, you know that you've got the coils wired up correctly. You wouldn't believe how often people get that wrong. But that means you've got a good circuit all the way through. Okay. Next, I've done that. The last test is just hot wire it, rather like we did here. Take the white wire from the Boyer box, connect it to the negative terminal on the battery, have the positive terminal on the battery to ground, and that way, and nothing else connected. That way, the only thing you tested is the Boyer on its own, and see if it'll start the bike. Lucas 4-position ignition switches used on 71, 74, 75 Commandos and 71, 72 Triumphs do tend to shake themselves to death after about 20 years. The 2-position ignition switches, Lucas ignition switches, never go wrong. I've never ever seen one go wrong. Okay, just to conclude, the last thing I'd like to talk about is fuses. British fuses are rated by their blow rate. So if you see a British fuse specified at 32 amps, that means it's designed to run a current of about 16 amps, and if it goes up to 32, then it'll blow. North American fuses are rated by their flow rate. So if you put a 32 amp fuse into your British bike, it'll have to go, the current would have to go to 64 amps rather, before anything will break. Okay, by which time the wires will have melted inside the harness and you're in big trouble. And unfortunately, I've seen that happen a few times. I hope you found this helpful, and I hope it's answered some of the more commonly asked questions. Okay, if you like my video, please subscribe to my channel.
Any question, any comments, so just leave on the bottom of this video.
Yeah,
we will appreciate. Thank you.
Oh, sorry, okay, and I'd appreciate it if you could leave any comments at the bottom of the video.
Yeah.